how much work I put into this?
No, not really, but what is this?
It's one part of my Rube Goldberg machine, which I plan to use to demonstrate Newton's laws of motion.
What is a Rube Goldberg machine, and what are Newton's laws of motion?
Well, let's find out with Team Picasso.
Hey, I'm Pia, Ira,
Kel,
Alden,
Seth.
and we're from Team Picasso, and we're here today to discuss Newton's
3 laws of motion.
We see things in motion all around us every day, and whenever something is moving, force is always involved. Force is essentially the push or pull on an object. For example, when I kick this ball, I'm applying force to push it. Newton's 3 laws explain the relations between an object and the forces acting upon it.
For us to explain Newton's laws of motion, we will use a Rube Goldberg machine. But you may be wondering, what's that? A Rube Goldberg machine can perform a simple task through a series of complex events. It is made up of everyday materials such as pens, notebooks, and toys. Using these materials, we can create simple machines such as ramps, dominoes, and pulleys. There aren't any rules when it comes to making these, which is why you can easily make it anywhere. Now that it's built, let's start it.
Okay, 1, 2, 3, go!
The first law of motion is known as the law of inertia. It states that an object will not change its motion unless a force acts on it. In other terms, whether an object is moving or not, nothing changes unless something else disturbs it. As you can see here, everything is at rest, for now. But once we tip over this domino, it starts a chain reaction. By tipping over said first domino, it disturbs the standstill state of the Goldberg machine. From that point on, the law of inertia can be seen all throughout the machine. The domino knocks over the ball then rolls down via ramp and knocks over another set of dominoes. You get the idea. With these, it is clear that inertia is one of the most common and most obvious to spot.
Whoa! Everything went by so fast! And this is because of the second law of motion, which states that when a force interacts with an object, the object moves and accelerates depending on its mass. But when the object interacts with the next one in chain, it transfers a force equal to its acceleration and its mass.
Newton's third law, better known as the law of interaction or action-reaction, can be observed all throughout this machine, and even in our day-to-day activities. This law states that with every action comes an opposite and equal reaction. You can see it in the string attached to the box. As the cup pulls down, it causes tension, this being the reaction. When the balls fall into the pool, it also bounces slightly as another reaction. From the first domino being pushed to the balls falling into the pool, every little force has been met with a reaction, regardless of how big or small.
As we are nearing the end of this video, let's have a recap on what Newton's laws of motion are.
The law of inertia states that an object stays at rest or in constant motion until another force acts upon it.
The second law of motion states that force equals mass times acceleration.
The third law of motion states that with each action comes an equal and opposite reaction.
We can observe Newton's laws in the motions of our daily lives. So the next time you see something moving, keep them in mind.
That's it for today's video, and may the force
Be with you.